Welcome to The Explainer. Today, we are taking a really structured, deep dive into a topic that honestly causes a surprising amount of confusion for operations directors and plant managers who are just trying to protect their facilities. You know, if you've looked into upgrading your safety systems recently, you've almost certainly seen this catch-all term thrown around, the fire alarm camera. But here's the catch. That's not actually a precise definition. It's kind of like calling a motorcycle and a minivan driving machines. Sure, it's true, but it covers completely different technologies. And choosing the wrong one? Well, that could literally mean the difference between preventing an event entirely and simply sitting back and watching it happen. So, in this explainer, we're going to break down what these systems actually are, how they work in the real world, and exactly how to choose the right one for your setup.
Okay, let's dive right into this. Here is our roadmap for today. We're going to breeze through the basic definitions and get straight to the good stuff. We'll cover the core difference, look at detection capabilities, map out the timeline of detection, talk about handling those annoying false alarms, and wrap up with a really practical executive decision guide.
So, Section 1, the core difference. Let's get into it.
To truly protect a facility, we absolutely have to split that vague fire alarm camera term right down the middle. We need to draw a hard line between how each of these systems actually sees the world around them. On one side, you've got video fire detection. This looks for visible evidence, stuff we can see. We're talking visible smoke, a flickering flame, or the specific way a smoke plume behaves. Now, on the flip side, thermal monitoring completely ignores what's visible to the human eye. Instead, it measures infrared radiation. So think of it this way. One looks for the visible signs of a fire that has already started, while the other is hunting for the invisible heat that builds up right before a fire happens.
Let's look at the video fire detection camera first. This is a visible light system that uses some really advanced AI algorithms to identify actual smoke and flame patterns. Solutions like Bosch AVIAN or AVIAN Vision are fascinating examples here, mainly because they can actually run their AI directly on your existing CCTV network, which is huge. Instead of waiting for smoke to lazily drift all the way up to the ceiling to trigger a traditional detector, which can take forever, the camera simply spots the smoke the exact second it appears in the room. It catches the event incredibly fast.
Now, a thermal monitoring camera is a fundamentally different beast. It measures infrared radiation emitted by surfaces to gather temperature data. A thermal system isn't just scanning a busy room and asking, hey, do I see a fire? It's actually asking a much cooler, much more preventative question. It's asking, is this specific piece of machinery hotter than it should be right now? It spots abnormal heat on equipment or raw materials well before a single wisp of visible smoke ever appears.
Moving right along to Section 2, Detection Capabilities Explained. So where do these fit in the real world? Well, video detection is an absolute game changer for early awareness. If you've got a massive facility with high ceilings and drafty spaces, traditional ceiling detectors are kind of like waiting for a snail to finish a marathon. Smoke just takes way too long to reach them. A video system, though, it watches the room directly. It catches events much faster and, crucially, gives your operators immediate visual proof of what's happening. Just keep in mind, it does have one sort of kryptonite. It needs a direct line of sight. If there's no visible smoke or flame in its view, there's no trigger.
Now, what's really fascinating about thermal monitoring is its dual purpose. Because it's measuring heat before ignition ever occurs, it doubles as a condition-based asset monitor. It's watching for friction in a bearing, an overloaded motor, a stress electrical panel. It actually learns the normal temperature baselines of your specific equipment over time. So it's really doing two jobs at once. It's warning the safety team of a potential fire risk, and it's giving the maintenance team a massive heads up on failing equipment before it causes some ridiculously expensive downtime. Let's transition to Section 3, the timeline of detection, and see how this all builds together. Walk with me through this timeline of a typical industrial fire. Starting way at the bottom, minutes after an event has actually started, smoke finally drifts up to the ceiling. This is where your traditional detectors sound the alarm. And honestly, by that point, it's pretty late in the game. Now, moving a step earlier, just seconds or maybe minutes after ignition, smoke or flame first becomes visible in the room. This is the exact sweet spot where video detection catches the event. But look at the very top of the timeline. Hours or literally even days prior to ignition, a bearing or a pile of material might start running hot. Thermal detection catches this abnormal heating condition long before smoke even exists.
I want you to let this sink in for a second, because this is arguably the single most critical distinction to take away from all of this. Ready? Video detects the fire event. Thermal detects the condition that creates it. If you just want much faster awareness of a fire that is already broken out, video is absolutely fantastic. But if your main goal is stopping ignition before it ever happens, thermal monitoring is the tool you need.
Okay, let's talk about the elephant in the room in Section 4, handling false alarms.
Anyone in operations knows that false alarms are the worst. They destroy operator trust faster than anything else. You get alarm fatigue, and people start ignoring the warnings. Now, video AI has to be incredibly smart to ignore things that look like a fire to a computer. Stuff like steam, changing shadows on the floor, or a passing truck's headlights. Thermal, on the other hand, faces a different challenge. It has to ignore harmless heat sources. That's exactly why advanced thermal systems have to use scene context. They need to know the difference between a failing overheating motor and a forklift that just happens to be driving past with a hot exhaust. You definitely don't want to page your response team every single time someone moves a pellet.
So, what does this all mean for you? Let's bring it all together in Section 5, the Executive Decision Guide.
This matrix right here translates all that technical science into clear operational strategy. Video shines in large spaces with high ceilings. It looks for visible smoke to give you incredibly fast awareness. Thermal, meanwhile, is perfectly tailored for specific assets. Think high voltage panels or huge piles of combustible materials. It looks for abnormal heat to give you proactive condition monitoring. Just remember the limitations. One absolutely needs visual evidence of the smoke or flame, and the other absolutely needs a direct line of sight to the hot surface itself. So, practically speaking, when do you opt for video detection? Well, choose it when you need the fastest possible detection of a visible event in massive spaces where smoke drift is just too slow. It is 100% the right choice when your team demands immediate visual confirmation on a monitor before rolling fire trucks. And honestly, it's highly efficient if you want to leverage the existing CCTV camera network your facility already owns and maintains.
Conversely, deploy thermal monitoring when heat is your earliest useful signal of risk. If you have supercritical machinery, high-voltage panels, or volatile combustible piles, thermal is essential. Choose it when you demand alerts before there is any visible smoke, and crucially, choose it when you want your safety team and your maintenance team sharing the exact same proactive data to prevent downtime. It's a win-win for both departments.
Now, the reality for most modern industrial plants is that these aren't actually competing technologies at all. They are complementary layers. You should absolutely choose to use both when a fire event would be exceptionally expensive or dangerous to your operations. If you're processing combustible materials, or if you have high-value equipment sitting right next to a high fire load area, you want that belt and suspenders approach. You layer AI video for broad facility-wide smoke detection, and then you aim dedicated thermal cameras directly at your highest-risk assets for that localized heat-first monitoring.
Now, before we wrap up, I have to give you a very firm absolute caveat here. Cameras do not replace certified life safety systems. Seriously, unless specifically approved by your local fire marshal or jurisdiction, these cameras are strictly early warning layers. Your code-required traditional alarms and your sprinkler systems, yeah, they must stay in place. These new camera technologies are here to help you see risk earlier. They are not here to let you bypass building codes.
And this brilliantly illustrates the whole point of our explainer today. This core quote from our source material really just sums up everything we've covered perfectly. If you only watch for smoke and flame, you are detecting the fire event. If you watch for abnormal heat, you may catch the condition that creates the fire. So I want to leave you with this final, strategic question to chew on. As you evaluate your own facility's safety and vulnerabilities, are you watching for the fire event? Or are you watching for the condition that creates it? It might just be time to walk your plant floor and map out exactly where you need visible smoke detection and where you desperately need that heat-first monitoring. Thank you so much for joining me for this explainer. Keep learning, keep analyzing, and we'll see you next time.